we should find out the number of hydroxyl groups present in the final product Q. Okay, let's start reaction. I can see this is heating. The moment you see heating, you will realize that it's the elimination. Elimination of what? Water. It's the acid catalyzed dehydration of alcohol into alkene product. That is what you're going to get. Now exactly you know that oxygen has got a lone pair of electron over it. So electron poor will move to electron rich. It's a common sense. Let's write what we are going to get here. Let me write them as it is. Here you get OH2 plus, right? Now exactly you know that along with the minus this will move out as neutral water. I know that plus minus together it become neutral water. So let me rub water molecule from here. Because minus went out, this become plus. So there is a formation of carbocation we can see. We know that in the mechanism in the syllabus we studied that acid catalyzed dehydration of alcohol into alkene. The reaction is rate determining step it has, that is a carbocation formation. So carbocation anyhow we have to show. Look at the nature of carbocation 1 2. So it's a secondary carbocation. So I want tertiary carbocation, something which is more stable. So I'm showing you people a CH3 minus shifting here. CH3 minus shifting. Right. So what we get on a methyl shifting, minus plus become neutral. Because from here minus went out, what remain is a plus. Rest all let's write them as it is. Right. Look at the nature of carbocation. It's 1 2 3 tertiary carbocation, more stable. That is what the expectation to get, right? Now finally what happened, removal of OH minus is done. Now removal of H plus, I know it's a beta elimination. I need to remove hydrogen from beta. I know this is alpha, this is beta, this is alpha and this is beta. So this is beta, absolutely. Now we have a two possibility. H is removed from here or from here. So let me show you. In a one case, let me show you removal of H plus from here. So minus plus, you will get to see the double bond here. Let me show that. Right. So another case, we are removing H plus from here. So that minus plus neutral pi bond you will get to see over here. So there are two possibilities. One possibility says that you are going to have a double bond here. Another possibility you are going to have a double bond here. So which is better? Let's see. Now when you look at this, okay, you have hyperconjugation. You can have a hyperconjugation here. You can here. You can here. If you look at this, you have 1 2 3 4. So you can even write hyperconjugation here or from here. If you look at this, you have a 1 2 3 4. So you can have a hyperconjugation here. So total how many hyperconjugation you saw? 3 here, 2 here, 1 here, 3 4 5 6. So total you have a 6 hyperconjugation structure for this. If you look at this, I'll write this in detail. You all can see 1 hyper, 2 hyper and 3 hyper. From here 1 hyper, 2 hyper, 3 hyper. If you look at here 1 2 3 4, you have a 1 hyper, 2 hyper. If you look at this 1 2 3 4, you have no sorry, this is not hyper. beta hydrogen, sorry. So it should be very next to doubly bonded carbon 1, very next to doubly bonded carbon yes, very next to doubly bonded carbon S. So 3, 6, 7, 8. The 8 hyperconjugation structure you got here. So this one is more stable. That's the reason why you get this, not this. So I'm writing what you're getting. That looks like this. Okay. Now finally it's given aqueous dilute KMnO4. The moment you see the reagent, you should realize that they are talking here about the Bayer's reagent. In first year hydrocarbons chapter, you studied about this. So I'll just explain you the Bayer's test. You assume that there is a compound which has a pi bond, unsaturated compound we may call it as. When you take alkaline KMnO4, you know that alkali is OH minus donor, KMnO4 is solid, right? You put it in water and prepare a solution, right? And you know that alkaline KMnO4 is oxidizing agent helping for oxidation by providing oxygen. So if you look at the reaction vessel, alkaline KMnO4 means full of OH groups. So double bond breaks, OH comes here and OH will be added here. The product you will get will be diol, all and all diol. Because the purple colored solution is utilized for the reaction, the purple color of the solution discharges. Students, when the compound is unsaturated, pi bond is there, easy to break, reaction takes place, purple color discharges. If the compound is saturated, it contains only single bond, only sigma bond, difficult to break, reaction won't take place, then reaction won't take place, purple color will remains, it won't discharges. So you have two different observations, right? Purple color won't discharge saturated compound, purple color discharges, it is unsaturated compound. You can distinguish, we call the test as Bayer's test. Now what I said, when it is alkaline KMnO4, right, so OH groups will be added up across the multiple bond. So we have a multiple bond here, so double breaks, you get OH addition across the multiple. Pi breaks, you will get to see the addition across the multiple bond. So total how many OH groups are present in the final product Q? The answer is 4. So option C we have to tick here.